Frequently asked questions. Do you still have questions about measuring 5G new radio base station? Help is at hand. Here is a compilation of questions that we have been asked recently concerning 5G and, of course, the answers to go with them. Do all 5G transmitter locations have beamforming antennas? No, not by a long stretch. Beamforming antennas for 5G services under 1 GHz would, for example, have a surface area of several square meters. Nobody really wants that. Also, it's considered a good idea to reuse the old 4G antennas, and most of these are not capable of beamforming. Beamforming antennas are additionally more complicated to manufacture and therefore more expensive. And beamforming antennas, even for frequency greater than 3 GHz, are still too big for many indoor applications. What does DSS stand for? DSS stands for Dynamic Spectrum Sharing. This basically means that a part of the spectrum of an existing service, such as a 20 MHz 4G system, can be occupied by a 5G service following a software update. For example, 5 MHz for the 5G service and the remaining 50 MHz for 4G. This division can be adjusted dynamically. The measurement is relatively simple. This type of system can be measured just like a standard 4G system. The fact that a part of the spectrum is occupied with a 5G protocol has no effect on the exposure measurement. The 5G option for the SRM can also measure the 5G part of the DSS, but this is unnecessary, as its contribution to the exposure has already been counted in with the 4G measurement. What does TDD mean, and how does TDD affect the measurement? 2G and 3G are based entirely on FDD technology. FDD stands for Frequency Division Multiplex and explains that the base station and the mobile subscriber transmit on different frequencies. This solution is hardly economical with bandwidth, as the base station downlink generally has to transmit far more data than the mobile unit uplink. 4G marks the introduction of TDD, time division duplex, technology into mobile communication, and it will be rolled out overall for 5G. In TDD, the base station and the mobile unit transmit in the same frequency band, but at different times. These time slots can thus be adjusted to the data throughput required. The use of FDD or TDD have very little, if any, effect on a wideband field strength measurement. TDD technology does, however, present a very real challenge for frequency selective measurement. A simple frequency selective measurement cannot distinguish between the uplink and the downlink if the time domain is not considered at the same time. Code selective measurement is a better solution here. Are there different options for TDD and FDD for 5G just like for 4G? No, signaling for 4G is different to 5G. Among other things, this means that the same 5G measurement routine can measure TDD as well as FDD signals. When is it best to use a long-term measurement with an area monitor, and when to use the code selective measurement? To answer that, let's look at what the measurement systems can do. The area monitor can continuously measure the actual value of the exposure and output the result as a graph versus time and upload this to the internet for everyone to see, for example. A code selective measurement with extrapolation is made at only one particular time, but can compute the maximum possible value. Of course, the result can also be published on the internet, but a graph versus time is hardly useful, as the measured value will just be a straight line. The only question is which approach is the best. Well, that's the one that is mostly acceptable for the general public or for the local residents. How do I deal with beamforming? The measurement procedure is the same as for without beamforming, except that the beamforming factor cannot be assumed to be 1, but has to be determined correctly. To do this, the antenna pattern for the traffic and signaling must be compared for the measurement location, for example. The antenna pattern that are required for this comparison must be obtained from the manufacturers or providers. Narda will shortly be providing further assistance on the subject of measurement on beamforming antennas. You can keep up to date with this through the Narda news ticker. What information do I need before I can make a code-selective measurement? In theory, if there is no beamforming, none. All the necessary system parameters can be measured on the spot using the SRM. However, depending on the system load condition, this measurement can be difficult. Let's therefore take a look at the parameters separately. Signaling frequency. The SRM needs this with an accuracy of 5 kHz. No problem to measure this using spectrum analysis if the load is low, for example at night, but not if the load is high. The value for a particular combination of provider and manufacturer is usually pretty constant, though. This means that once it has been measured, the information can also be used for other location. System bandwidth. Easy to determine with the maximum result type in spectrum mode. A lot of traffic helps. TDD factor. Can be determined at high traffic levels in scope mode. See the information in part 5 of 5G in a nutshell. If the measured value is below the limit value, the TDD factor can simply be left at 1. It cannot be greater than 1 anyway, only smaller. The measurement procedure with beamforming stays the same, with the addition of the determination of the beamforming factor. This is very complex to determine by measurement and practically impossible without the cooperation of the provider and the use of additional measurement equipment or devices that can selectively manipulate the traffic beam. This goes against the intention of performing measurement independently of the provider. It is therefore better to calculate the beamforming factor from the antenna pattern. This also requires information from the provider, but can be asked for later if necessary. The provider does not therefore have to be present for the measurement or to set the system up. The actual code-selective measurement can be performed completely independently. It is only necessary to record the exact position of the measurement in order to precisely determine the beamforming factor, which is dependent on the location. Are there any national or international standards that describe the measurement procedure? The committees in the ITU and IEC are working hard on this. Switzerland has already published a complete description which also includes beamforming antennas. Germany should follow by the end of 2021. To what extent are the new limit values for 5G? 5G or beamforming has no effect on the limit values. Most of the EMF limit values are defined for frequencies up to 300 GHz, which also covers the 5G services in frequency range 2. The effect of 5G is thus limited to the way that the measurement is performed. How do I measure 5G services in frequency range 2? Narda will be offering an antenna that will extend the existing SRM 3006 frequency range up to frequency range 2. This antenna will cover the frequency range from 24.25 to 29.5 GHz. There will be two different reception characteristics, either that of a horn antenna or omnidirectional. The SRM 3006 will need a software update to use this antenna. This can be done on the spot. Are there also isotropic measurements in frequency range 2? Isotropic antennas are not available. Horn antennas are widely used in this frequency range, but are extremely directional. The best compromise is an omnidirectional antenna. What about a frequency selective measurement of the SSS? This also can be done with the SRM. However, the measurement cannot differentiate between different cells. It also can be affected by cell phones in TDD network. And it is practically impossible to cleanly measure the synchronization signals at high traffic levels. Do measurements also have to be made in campus or industrial networks? Of course. And because the people generally present in such areas are not likely to be so-called RF workers who have been trained and equipped for working in electromagnetic fields, The applicable limit will be those for general public. What about 60 kHz subcarrier spacing STS? Subcarrier spacing of 15, 30 and 60 kHz are defined for frequency 1. A 5G system can switch dynamically between this spacing or use a mixture of spacings. However, this only applies to the traffic signals. They are fixed for the SSS PBCH and can only be either 15 or 30 kHz. 60 kHz therefore plays no part in FR1 for the measurement of the SSS. And what about a code-selective measurement in frequency range 2? So far, no measurement procedure exists for this. The subcarrier spacing in FR2 is 60 and 120 kHz. The SRM 3006 cannot decode this spacing as far as we know right now. What do SSS 0 through SSS 7 mean? SSS stands for Secondary Synchronization Signal and is a part of the SSPBCH, which distributes basic information within the cell. This signaling can be radiated within a segment with or without beamforming. If beamforming is active, the beam can be projected in up to 8 different directions, one after the other. Each of these is assigned an index, that is the value SSS 0 through SSS 7. Without beamforming, the provider can assign the SSS any value between 0 and 7. The Narda team wishes you every success in measuring 5G new radio stations. Bye bye.